Hello friends, welcome to session 6. The topic of today's session is KNN classification. Okay. Remember, we said we were going to look at a couple of AI learning models. We looked at the Bayesian classification last time, and today we are going to look at another model called the KNN classification model. Okay. Let's see what this is about. Okay, we often begin our sessions with an assignment, right? And like I said, I sort of design these assignments in order to make a point or two. Right? The assignments are fairly simple. This one was a walk in the park. I mean, it was literally a walk in the park. So it would be good if you could do these assignments before you jump into these sessions, because I'm sure you'll find them beneficial, right? So here was the assignment we looked at last time. Walk through a park with lots of trees, occasionally pick a leaf on the ground and guess which specific tree the leaf belonged to. That is what you were supposed to do. तो हमने लास्ट टाइम एक असाइनमेंट देखा था और मैंने भी ये असाइनमेंट किया. तो मैंने जब ये असाइनमेंट किया हुआ कुछ यूं. मैं घर से निकल पड़ा, अकेले ही निकल पड़ा. शाम का वक्त था, मौसम सुहाना था और मैं पेड़ों के बीच चलता रहा. कुछ देर चलने के बाद मेरी नज़र एक गिरे हुए पत्ते पे पड़ी. तो मैं अपने असाइनमेंट के बारे में सोचने लगा. कुछ देर वहीं खड़ा होके असाइनमेंट के बारे में सोचता रहा. तो अचानक पेड़ों के बीच से हवा के चलने की आवाज़ आई. देखा तो कई और पत्ते उसी जगह आके गिर रहे थे. कुछ और पत्ते उसी जगह आके गिर रहे थे. 7-8 पत्ते इस पेड़ से आए, 4 पत्ते इस पेड़ से आए और 2-3 पत्ते इस पेड़ से आए. और इस तरह मुझे अपने असाइनमेंट का जवाब मिल गया. सो इफ योर स्ट्रैटेजी टू डू दिस असाइनमेंट वाज आल्सो टू वेट फॉर अ व्हाइल and observe some training data come in, you would be channeling the essence of the KNN algorithm. Okay, remember, this is a course on AI/ML, and when you are attempting to solve problems with AI/ML, the fundamental question at the back of your mind should be, where am I going to get my training data from? Okay, so that should be the question at the back of your mind. And if that question was driving your approach to this assignment, the approach to solving this assignment, it would have been very clear how to go about doing it. तो ये AI/ML का कोर्स है. हमें हमेशा ध्यान रखना चाहिए, ये सवाल हमारे मन में हमेशा होना चाहिए कि हमारा ट्रेनिंग डेटा कहाँ से आएगा. ठीक है, तो इस तरह से हमें इन प्रॉब्लम्स को अप्रोच करना होता है. Let's see what KNN classification is. KNN stands for K Nearest Neighbor classification. K is a variable, it's supposed to be a number, we just call it K. K Nearest Neighbor classification. Okay. To understand what KNN classification is, how it works, let's go back to the example that we have been working with from day one, right? We are going to tweak the example a little bit. We are going to sort of modify it a little bit. What we are going to do is we are going to predict what men are wearing, and we are going to perform the prediction based on their age and income. So we will only deal with men in this particular example, and we've created 3 groups. I mean, group A is men who are wearing pajama and dhoti. Group B are men who are wearing shorts. Group C are men who are wearing trousers or full pants, etc. Okay, so imagine you sort of sat in a restaurant or went to a busy area and observed these men and sort of gathered their information. You gathered your test, your training data, and your training data was essentially age, income and attire, right? So attire was what you had to predict, but in your training data you gathered information on attire as well. You asked people you asked men what their age and income was. You tabulated all of this information here. Attire you classified based on the groups, right? So I have colored these rows. This was your training data which you decided to feed to your AI model. Okay, and then the purpose of this exercise was, when confronted with a person you had never met before, if you were told the man's age and income, you should be able to predict what they were wearing, in which group they would fall in, right? So that was the classification example. That is the classification example we are going to deal with over here. Okay, visual representation. So KNN is best understood with a visual representation, and what we are doing here is essentially plotting. We are plotting the training data on a chart. Okay, there are two observed variables in the training data, age and income. So this is easy to plot on a piece of paper, on a chart, right? Age and income. Age is on the x-axis, income we put on the y-axis, and each of the points here on the graph represents one sample of the training data. Okay, and the colors of these points are basically what you observed those people in the training data were wearing. So for example, if you had in your training data, you had a 90-year-old person right here, a 90-year-old person in your training data, and he had an income of 20,000 rupees, 20,000 rupees right here, and you had observed that he was wearing a pajama or a dhoti, and therefore this point is blue right here. Okay, similarly in your training data you had a person who was approximately 27 years old right here, 27 years old right here, and his income was 1 lakh rupees, and therefore he was wearing trousers, and therefore you drew this red point right here. Okay, so this is the way you plotted all the training data on this chart. Okay, now suppose you are told that there is a 37-year-old person, a 37 or a 36-year-old person right here, right? 37, 36 is his age, and let's say his income was 83,000 rupees on the y-axis. So this black dot right here would be that person, and you are supposed to predict on the basis of your KNN model what the person would be wearing. Okay, the KNN model goes as follows. What you do is you first pick a value of k, okay, and I'll tell you how you pick this value, but suppose you were using k equal to 5, okay. What you would do is, for this black point right here, you would find the 5 nearest neighbors, okay, the 5 nearest neighbors from among the training data. The 5 nearest neighbors for this black point are 1, 2, 3, 4 and 5, right? These are the 5 nearest neighbors, and you would see what majority of them were wearing. So here 3 of the nearest 5 neighbors were wearing pajama or dhoti, and 2 were wearing trousers. And since the majority is pajama / dhoti, you predict that this individual with an income of 37,000 rupees, whose age is 37 and whose income is 84,000 rupees, is likely to be wearing pajama or a dhoti as well, right, on the basis of the nearest neighbors. Suppose you had another person, okay, right here, a person whose age is 80 years old, 79 maybe, and whose income is 40,000 rupees. What you do is you look for this person's, his 5 nearest neighbors. 5 nearest neighbors would be 1, 2, 3, 4, 5, right? 5 nearest neighbors. These neighbors are not as close as in the earlier case, but still you need to take 5. And you observe that all of them are wearing a pajama or a dhoti, and therefore you predict that this person is also going to be wearing a pajama or a dhoti. Let's say you had another person, another test input. This was a youngster, about 15 years old, had barely any income, and you looked for his 5 nearest neighbors. 5 nearest neighbors, out of the 5 nearest neighbors, 3 of them were wearing shorts, 2 of them were wearing trousers. So you predict that this particular person is also likely to be wearing shorts. There are 3 green points and 2 red points. Okay, so this is how the KNN algorithm works. You look at the nearest neighbors and predict what the test input is likely to be doing. Okay, the underlying philosophy or the underlying principle behind the KNN is that people with roughly similar observed parameters are going to exhibit roughly similar behavior. right? So this is the underlying principle. So what are we saying? We are saying that people of roughly similar age and roughly similar income, the cluster of people with roughly similar age and roughly similar income are likely to be wearing the same attire. Okay, this is the underlying philosophy. It's fairly intuitive, it makes sense. That is the underlying philosophy behind KNN, K Nearest Neighbors. Okay. तो हम KNN एल्गोरिथम के बारे में इस टाइप से सोच सकते हैं कि हम ये सब ट्रेनिंग डेटा एक ग्राफ पे प्लॉट करते हैं. आयु या एज रहेंगी अपने एक्स एक्सिस पे, इनकम रहेगा वाई एक्सिस पे, जैसे हमने देखा ट्रेनिंग डेटा में, और पूरे ट्रेनिंग डेटा को हम इस ग्राफ पे प्लॉट करते हैं. और KNN एल्गोरिथम इस तरह से जाता है कि हम किसी टेस्ट इनपुट के सबसे करीबी पड़ोसी देखते हैं. अभी यहाँ हमने k इक्वल टू 5 लिया है, तो 5 सबसे करीब पड़ोसी देखते हैं और उनमें जो मेजॉरिटी ने पहना होगा उसी को हम ये टेस्ट इनपुट को असाइन कर देते हैं. तो इस प्रकार से सबसे करीबी पड़ोसी जो होते हैं ट्रेनिंग डेटा में, उनके आधार पे हम KNN में क्लासिफिकेशन करते हैं. Okay, so to formalize what we just said, find the K nearest neighbors from the training data, find the class such that more neighbors belong to that class than any other class. This is what majority wins, right? And you assign the test point to that particular class. So हमने जैसे कहा, सबसे करीबी पड़ोसी पॉइंट्स ट्रेनिंग डेटा से हम देखते हैं और उनमें जो मेजॉरिटी रहेगी उस क्लास को हम टेस्ट इनपुट को असाइन कर देते हैं. तो ये रहा KNN क्लासिफिकेशन. important details. Okay, so question to ask is, how do you know the value of K? What is the value of K to use? And the second important question is, what does nearest mean? So nearest implicitly has a concept of distance underlying it, right? So what is this concept of distance and what does nearest mean? This deserves a little bit more attention. तो K की वैल्यू हम कैसे लेते हैं? यहाँ हमने इस उदाहरण में K इक्वल टू 5 ली थी, लेकिन हम K की वैल्यू कैसे सिलेक्ट करते हैं? और सेकेंडली हम जब कहते हैं कि सबसे पास जो पड़ोसी हो, सो उसका मतलब एक्चुअली क्या है, डिस्टेंस का मतलब क्या है, ये दूसरा सवाल है. और ये दो बहुत ही महत्वपूर्ण चीज़ें हैं, तो हम इसके बारे में थोड़ा सा बात करेंगे. डिटरमाइनिंग द बेस्ट K. How many nearest neighbors should we consider? What is the best value of K? Now, the answer, the best value of K depends upon the problem and the training data, etc. Okay, so there is no globally best value of K. So it's not as if always K equal to 10 is the best value to use or K equal to 5 is the best value to use. The value of K to use depends upon the problem that you're trying to solve and the nature of your training data. Okay, so how do we go about finding the value of K? Here is the method that is typically employed, right? So you had your training data, you have your training data, and the first thing you do is you divide the training data further. You divide the training data further into a training set and a verification set, perhaps in a 70-30 ratio. Okay, so this training data, about whom you already know the attire of all the people in this training data, you further divide into a smaller training set and set aside the remainder in what you call a verification set. Okay, then do this for K equal to 1, 2, 3, 4, etc. Okay, do this for all values of K. Do the following for all values of K. Run the KNN algorithm on the verification set to determine the accuracy. Okay, so run the KNN algorithm on the verification set whose answers you already know, so you can determine the accuracy for each K. You run the KNN algorithm for each value of K and note down the accuracy. Okay, and then finally you use the K for which the accuracy is the highest. So this is how you determine the best K for your problem. So if I wanted to represent this graphically, what would typically happen? Typically happen, like I said, this thing would change from problem to problem, but typically for small values of k, your accuracy would probably be small, and your graph would sort of go up as your k increases. At some point in time it would probably stabilize, and then it would start going down again. Okay, and what you have to do is look at the k for which your accuracy was the highest and select that particular k. So k was perhaps 8 over here, right? So that is the way you find the best k. If it's not easy to sort of find the best k in one set of experiments, what you do is you reshuffle your training set and verification set, run the same process again and see if you get a clear winner in terms of k. तो हम k इस प्रकार से फाइंड आउट करते हैं कि ट्रेनिंग डेटा के हम दो भाग बनाते हैं, एक ट्रेनिंग सेट होता है, एक वेरिफिकेशन सेट होता है, और वेरिफिकेशन सेट पे हम KNN एल्गोरिथम बार बार चलाते हैं अलग अलग k के वैल्यूज़ के लिए. इस प्रकार का ग्राफ अगर आ जाता है तो उसमें जिसके लिए एक्यूरेसी सबसे ज़्यादा हो वो k हम सिलेक्ट करते हैं. सो दिस इज़ द वे यू फाइंड द बेस्ट k फॉर योर KNN एल्गोरिथम. Concept of distance, this was the other important thing I said we would talk about, and this thing gets a little technical, so if you don't follow all of it, that's quite fine. ये थोड़ा सा टेक्निकल होगा तो हिंदी में अनुवादन करना शायद मुझे थोड़ा मुश्किल हो, लेकिन आप समझने की कोशिश कीजिए. ये हम बात कर रहे हैं इस बात की कि हमने जब कहा कि सबसे करीबी पड़ोसी, तो करीबी का मतलब क्या है, ये हम बात करने वाले हैं. So here is the common distance metric that you would see in most books and lectures and so on, right? So this is the concept of distance that is usually talked about. Distance between 2 points x and y, where n is the number of dimensions, which is basically the number of variables. For p equal to 1, this is really the Manhattan distance. It's called the Manhattan distance, p equal to 1. Okay, and p equal to 2 would be the Euclidean distance. P equal to 2 would be the Euclidean distance, which you study in coordinate geometry in your high school, right? Your typical the concept of distance that you always sort of learnt about. So this is what is proposed to be used as distance in the KNN algorithm in most available books and lectures and so on and so forth. But when you apply this to practical scenarios, there is a problem. Okay, so I'll tell you from my experience what the problem is. I'll keep using our example of age and income and so on, but I'll explain to you what the problem is. So look, what we plotted here is age on the x-axis, and we plotted the income in rupees on the y-axis, right? So income in rupees and age in years. And we are somehow trying to say here, I mean at least in this graph, that somehow a difference of 20,000 rupees in income, a difference of 20,000 rupees in income is going to give the same effect as a difference of 10 years in age. Right? I mean, that is effectively what the Euclidean distance would suggest. But that's clearly not true. I mean, how can age and income are like apple and oranges, right? There is no such formula that says that an age difference of 10 years is equivalent to a income difference of 20,000 rupees. So this whole idea of a Euclidean distance on using it for solving the KNN doesn't always work for practical problems. Right? So how do we then come up with a concept of distance, right? तो हिंदी में मैं बता दूं तो हमने जैसे कहा KNN क्लासिफिकेशन में आपको पड़ोस के पॉइंट्स देखने पड़ते हैं, लेकिन उससे तो यही लगता है कि करीबी 10 साल की उम्र की जो डिफरेंस है वही 20,000 रुपए की इनकम के डिफरेंस के बराबर है, लेकिन ऐसा तो हो नहीं सकता. मतलब एज अलग चीज़ है और इनकम अलग चीज़ है, और दोनों को कंपेयर करना ठीक बात नहीं है. तो ये प्रॉब्लम हम कैसे सॉल्व करते हैं? सो one thing that you can do is you can insert over here a parameter alpha I. Okay, so for each for each of the variables you introduce an alpha I, and the idea behind alpha I would be to sort of equalize the effect of different parameters on the distance. Okay, so this is something that you could do to modify the idea of distance in KNN when you apply it to practical problems. Okay, so to recap, in the KNN classification scheme, training is simply the recording of training data using which the KNN algorithm can be executed by the computer. So KNN में ट्रेनिंग का मतलब यही होता है कि वो सब ट्रेनिंग डेटा आप रिकॉर्ड करके रखें और जब कोई टेस्ट इनपुट आता है उसके करीबी पड़ोसी देखने के लिए उसका इस्तेमाल करे. तो ये होता है ट्रेनिंग डेटा का रोल KNN में. Some things are about training data we discussed earlier are obvious again in this particular case. More the training data, closer the nearest neighbors, and hopefully the better the accuracy of your classification engine. Secondly, when the training data changes, clearly the neighbors would change and your results would change. And finally, the training data should cover all input types, meaning on the graph, it should be distributed over the entire region so that all the regions are covered as far as test inputs are concerned. तो हमारा ट्रेनिंग डेटा ज़्यादा होना चाहिए, सभी जगह डिस्ट्रीब्यूटेड होना चाहिए ताकि हमारे क्लासिफिकेशन की एफिशिएंसी बेहतर हो. ओके, सो दिस इज KNN classification. Okay, a non-intuitive fact. I want to draw your attention to something that is a little bit non-intuitive. Remember, I had said in the first session that our entire purpose of this series was going to make things relatable, intuitive, easy, etc. So I have particular interest in facts that are non-intuitive. Okay, and I try to bring them out. There is one such fact that I want to draw your attention to. Classification accuracy is less than 100% on training data. Okay, so whether it's the probabilistic classifier or KNN classifier, the classification accuracy on the training data is not 100%. Okay, so imagine that you train the classifier on your training data and you use the training data as the test data. Even in that case, your classification accuracy would not be 100%. It would be less than 100%. Now, this is extremely non-intuitive, and I feel not enough attention is paid to this fact in our usual textbooks or lectures and so on. But this is important because it goes to the heart of what AI models really do. Okay, तो हिंदी में बता दूं तो हम अगर हमारा क्लासिफायर ट्रेनिंग डेटा पे ही चला दे तो फिर भी वो गलतियां कर बैठता है, उसकी एक्यूरेसी 100% नहीं होती है. तो ये थोड़ा सा हजम नहीं होता, राइट? मतलब अगर आप आपके बच्चे को पढ़ाते हो और कुछ प्रॉब्लम्स उसको सिखाते हो और वो परीक्षा के लिए जाता है, तो परीक्षा में कुछ नए प्रॉब्लम्स आते हैं तो उस पर वो गलती कर बैठता है, आप समझ सकते हो. लेकिन जो प्रॉब्लम्स आपने उसको सिखाए हो, अगर उसी प्रॉब्लम्स पे वो परीक्षा में गलती कर बैठे तो शायद आपको गुस्सा होना, समझ सकते हैं, आपको गुस्सा हो सकता है, बराबर? तो अगर एक क्लासिफायर आपका दोस्त होता तो आप उसे कहते कि भाई तुमसे ट्रेनिंग डेटा नहीं पेला जाता, तुम टेस्ट डेटा पे क्या तीर मारोगे, राइट? तो ये बड़ी ही नॉन इंट्यूटिव सी बात है. तो इसके लिए हम इसके बारे में थोड़ी सी बात करेंगे और ये प्रश्न महत्वपूर्ण है, इसलिए इसका जवाब मैं दो तरीके से दूंगा. आई विल आंसर दिस क्वेश्चन फ्रॉम एन algorithmic perspective as well as from a human acceptance perspective. So algorithmic perspective means why does the Bayesian classifier or the KNN classifier behave in this way, and human acceptance perspective is why do we tolerate a classifier which behaves in this manner, right, which cannot even give 100% accuracy on training data. Let's go with the human acceptance perspective first, right? So human acceptance perspective, the first thing to note is that what matters is the accuracy on test data, and performance on training data is completely immaterial. Okay, so we just don't care about the training data. All that matters is the accuracy on the test data. So मैं ये कहता हूँ कि हमारा जो परीक्षा का, बच्चे के परीक्षा का उदाहरण जो मैंने बताया वो उतना सही नहीं है, मतलब ठीक उदाहरण नहीं है, क्योंकि यहाँ हम ट्रेनिंग डेटा के बारे में सोचना ही नहीं चाहते. हम केवल टेस्ट डेटा के बारे में ही सोचना चाहते हैं, तो वो उदाहरण थोड़ा सा गलत है। दूसरी चीज, algorithms are designed to minimize the overall error ratio over large number of test inputs rather than getting a particular input correct. Okay? तो हमारा फोकस यही रहता है कि ओवरऑल एरर रेशियो टेस्ट इनपुट पे बेहतर हो, ना कि किसी पर्टिकुलर इनपुट पे सही हो। Recognize that training data itself could have outliers और errors, तो ट्रेनिंग डेटा में भी हमारे गलतियां हो सकती है, तो ये चीजें हमें ध्यान में रखनी चाहिए। From an algorithmic perspective, remember that the Bayesian classifier is built around conditional probabilities from training data, which are not 0 and 1, right? Because training data has outliers. So, for example, if these were the 4 conditional probabilities that you found, it's not as if this was 1 and these were 0, right? I mean, all of them were sort of numbers between 0 and 1. Probably this was the maximum, but it was not 1. And in this particular situation, therefore, because this probability is not 1, on the training data itself, the Bayesian classifier would make a certain number of mistakes. As far as the KNN algorithm is concerned, when you plot the graph, k equal to 1 may not necessarily be the best k. K equal to 1, if k equal to 1 was the best, then your algorithm would do 100% job on training data, but k equal to 1 may not necessarily the best. तो ये reasons है कि algorithm के हिसाब से भी अगर देखा जाए तो हमारे ट्रेनिंग डेटा पे भी हमें 100% एक्यूरेसी नहीं मिलती है, तो ये बात हमारे ध्यान में होनी चाहिए जब हम ये सिस्टम्स डिज़ाइन करते हैं। Okay, so that's all I had to say about KNN really, and we should prepare for our assignment for the next session, which will be the last in the series of our introductory sessions. And this assignment is as follows: go to any job portal and check out AI related jobs. Okay, तो आपको किसी भी जॉब पोर्टल पे जाना है और वहाँ AI के जितने भी जॉब्स हैं उनके बारे में थोड़ा सा पढ़ना है। तो ये एक्सरसाइज में मज़ा आता है, अगर आप एक्चुअली जॉब नहीं ढूंढ रहे हो तो ये पढ़ने में काफ़ी मज़ा आता है। देख लीजिए, 15-20 मिनट उस पर स्पेंड कीजिए। Go to any job portal, check out AI related jobs. That's the assignment for next time. Summary. Okay. So what we learnt in this session was that KNN is an AI mechanism that relies on nearest neighbors for classification, right? The philosophy of majority wins, right? And learning is simply recording the training data so that KNN logic can be run. तो यहाँ हमने देखा इस लेक्चर में कि KNN में सबसे करीबी पड़ोसी जो होते हैं ट्रेनिंग डेटा में, उनके हिसाब से उस हिसाब से क्लासिफिकेशन किया जाता है, और लर्निंग का मतलब यही होता है कि हम पूरा ट्रेनिंग डेटा रिकॉर्ड करके रखते हैं KNN लॉजिक चलाने के लिए। तो आज के लिए इतना ही था। दैट्स ऑल आई हैड फॉर टुडे। This is the end of the session, and I will meet you in the next session, which will be the last in this introductory series.